Logarithm of 3 divided by 3 by 2. Just take this 3 by 2 the numerator, it will comes 2 by 3, 3 gets cancelled, log 2 which is the required RHS. Log m plus log n is log m into n. So this can be written log m is 9 by 49 into 49 by 9. 9 gets cancelled, 49 gets cancelled one time. Logarithm of 1 is equal to 0 which is the required RHS. Log m minus log n is equal to logarithm of m by n. So here m is 4 by 7, n is equal to 4 by 14. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding the laws of logarithms and few simple problems based on the laws of logarithms. Now in this session, I am going to take the problems for 3 and 5 marks on laws of logarithms. Now let us come to the first problem. Now let me recall all the laws of logarithms. So the first law is logarithm of m into n to base a is equal to log m to base a plus log n to base a. This is the first law. And the second law is logarithm of m by n to base a can be written as log m to base a minus logarithm of n to base a. And the third one, logarithm of m to the power n to base a is equal to n log m to base a. And the last one is base change rule. What we have studied, logarithm of a to base b is also equal to 1 over logarithm of a to base b. Or this can also be written as changing the base to k, log b to k, log of b to base k divided by log of a to base k. These are the laws which we have studied in the previous class. Now based on this, we will solve the problems. Now come to the first problem. This is very important problem for 3 marks. Now prove that logarithm of 9 by 5 plus logarithm of 15 by 9 minus logarithm of 3 by 2 is equal to log 2. Now let us take LHS. This is a very simple problem. Logarithm of 9 by 5 plus logarithm of 15 by 9 minus logarithm of 3 by 2. This is given LHS. Now if you observe carefully, this is log m plus n. Log m plus n is nothing but log m into n. This is logarithm of 9 by 5 into 15 by 9. Log m into log n is log m plus n minus this log 3 by 2 as it is. Now cancel the terms which gets cancelled. So here this 9 and 9 gets cancelled, 5 3s are 15. So this is equal to log 3 minus logarithm of 3 by 2. Again this is equal to, since this is of the form log m minus log n, log m minus log n is log m by n, second formula. So this can be written as logarithm of m by n, 3 divided by 3 by 2. See, log m by n is log m minus log n using second formula. So yes, second law. Right. Now this can also be written as logarithm of, take this 2 by 3 to the numerator, this becomes logarithm of 3 divided by, this goes to the numerator, 2 by 3. So 3 by 2 becomes 2 by 3, cancel the terms, 3 and 3 gets cancelled. That's equal to log 2 which is the required RHS. That's it. That is what we are going to determine. So that is to be proved, RHS. See here, log 9 by 5 plus log 15 by 9 minus log 3 by 2 can be written as logarithm of 9, log m plus log n is log m into n, 9 by 5 into 15 by 9 minus logarithm of 3 by 2. 5 3s gets cancelled, 9 gets cancelled, log 3 minus logarithm of 3 by 2. This is of the form log m minus log n is log m by n. So we can write log m by n according to second law. So logarithm of 3 divided by 3 by 2. Just take this 3 by 2 the numerator, it will comes 2 by 3, 3 gets cancelled, log 2 which is the required RHS. That's it. The answer is log 2. That's it. Hope you followed. Okay. Now let us come to a similar problem. Take a similar problem, same problem. Prove that 2 log of 3 by 7 plus logarithm of 49 by 9 is equal to 0. Now what is given? Let us take LHS. This is given LHS. 2 logarithm of 3 by 7 plus logarithm of 49 by 9. Okay, now again using law of logarithms, we know logarithm of m to the power of n to base a is equal to n log m to base a. So this is of the form 2n log m. N log m is log m to the power of n. So here n is 2 log 3 by 7 whole square plus logarithm of 49 by 9 as it is. Now this can also be written as logarithm of, cube this 3 square by 3 square divided by 7. 3 square is 9 divided by 7 square is 49 plus logarithm of 49 divided by 9. Now if you observe carefully, this is of the form log m plus n. Log m plus log n is also equal to logarithm of m into n. Log m plus log n is log m into n. This is log m plus log n is log m by n. Log of 4 by 49 into 49 by 9. This is equal to logarithm of 9 by 49 into 49 by 9. So these two gets cancelled is equal to 1. Logarithm of 1 is 0, which is the required RHS. That's it. Logarithm of 1 is 0. Okay. See here, LHS 2 log 3 by 7 plus log of 49 by 9. This is log m to the power of n plus log 49 by 9. So logarithm of 3 square is 9 by 49 plus logarithm of 49 by 9 as it is. Log m plus log n is log m into n. So this can be written log m is 9 by 49 into 49 by 9. 9 gets cancelled, 49 gets cancelled one time. Logarithm of 1 is equal to 0, which is the required RHS. That's it. That is to be proved. Now let us come to the next problem. Same type. Prove that logarithm of 7 by 8 plus logarithm of 32 by 49 minus logarithm of 4 by 14 is equal to log 2. Same as that of the first problem. Okay. Let us come to the next problem. Prove that log 7 by 8 plus logarithm of 32 by 49 minus logarithm of 4 by 14 is equal to log 2. Now let us take LHS logarithm of 7 by 8 plus logarithm of 32 divided by 49 minus logarithm of 4 divided by 14. Now this is of the form log m plus log n. Log m plus log n is log m into n. 7 by 8 into 32 by 49 minus logarithm of 4 by 14 as it is. Okay. Now cancel the terms, which gets cancelled. This 7 sevens are gets cancelled. Logarithm of 8 fours are 32. This is equal to 4 by 7 minus logarithm of 4 by 14. See here, log m plus log n is log m into n. Log of 7 by 8 into 32 by 49. 7 sevens are 49. 8 fours are 32. So log 4 by 7 minus log 4 by 14. Again this is of the form log m minus log n. Log m minus log n is equal to logarithm of m by n. So here m is 4 by 7, n is equal to 4 by 14. So this can be written as log m by n. M is 4 by 7 divided by 4 by 14. So this can be written as logarithm of 4 by 7 as it is, and this goes to the numerator 14 divided by 4. So 4 gets cancelled, 7 2s gets cancelled, that's equal to log 2, which is the required RHS. That's it. The required answer is logarithm of 2. That's it. Very simple. Log m plus n is log m into n minus this is same. Here you will get 4 by 7 minus log 4 by 14. Again this is log m minus n is log m by n. 4 by 7 divided by 4 by 14. Just take this to the numerator. It will become 14 by 4. 4 gets cancelled. 7 2s are 14. So what is remaining is log 2. So the required answer is log 2, which is the proof, which is required answer, that is which is required RHS log 2. Okay. Let us come to this problem. Prove that, I'll take one more problem. Prove that, this is very important, logarithm of a to base b is equal to logarithm of a to base b is equal to logarithm of a to base b divided by 1 plus log c to base b. Logarithm of c to base b. This is an important problem indeed. So prove that logarithm of a to base b is logarithm of a to base bc is equal to logarithm of a to base b 1 plus logarithm of c to base b. Okay. Now let us take LHS. What is to prove? Prove that log a to base bc is equal to log a to base b divided by 1 plus log of c to base b. Let us take LHS. LHS is logarithm of a to base b. Now using base change rule, change the base to b. So this can be written as logarithm of a to base b divided by logarithm of bc to base b. So the base must be b here. So this can also be written as, since we know logarithm of m into n is equal to logarithm of m plus logarithm of n. So this can be written as numerator is same log a to base b divided by the denominator, this is logarithm of m into n. M is b, n is c. This can be written as logarithm of b to base b plus logarithm of c to base b. Since you know what is log b to base b, logarithm of any number to same base is equal to 1. So this can be written as logarithm of a to base b divided by log b to base b is 1 plus logarithm of c to base b, which is the required RHS. See, log a to base b divided by 1 plus log of c to base b, which is the required RHS. That's it. Very important problem for 3 marks. OP for just changing the base to b. That's it. Okay. Now let us come to the next problem. Take this is an important problem indeed. Prove that logarithm of a square to base b square into logarithm of b square to base c square into logarithm of c square to base a square is always equal to 1. Now let us write the LHS. Logarithm of a square to base b square into logarithm of b square to base a square into logarithm of c square to base a square. Now just use base change rule, that's it. Now changing the base to, let us take k, a constant k. Now this can be written as, using base change rule, log of a square to base k divided by logarithm of b square to base k into logarithm of b square to base k divided by logarithm of c square to base k into logarithm of c square to base k and logarithm of a square to base k. Now cancel the terms which gets cancelled. See, log of b square to base k gets cancelled, log of c square to base gets cancelled, log of a square to this gets cancelled, everything gets cancelled. That's equal to 1, which is the required RHS. That's it. Very simple problem for 3 marks. Just change the base to k. That's it. So log of a square by log of b square, log of b square by log of c square, log of c square by log of a square, everything gets cancelled. That's equal to 1 into 1 into 1 is 1. You will get 1 as the answer. That's it. Very simple problem indeed. Okay. Now let us come to the next problem. So if log x to base k plus log y to base k plus log z to base k is equal to 0, then show that x, y, z is equal to 1. This is also a simple problem and important problem. Write down what is given. Given equation is logarithm of x to base k plus logarithm of y to base k plus logarithm of z to base k is equal to 0. Now if you observe carefully, this is of the form log m plus log n plus logarithm of p is equal to logarithm of m into n into p to base a, if it is a. So this is bases are same, log x to base k, log y to base k and log z to base k. Therefore this can be written as logarithm of x into y into z to base k is equal to 0. Okay, since you know the value of logarithm of 1 to base k is equal to 0 here. Logarithm of 1 is 0, or therefore we can write this logarithm of x, y, z to base k is equal to, here this is logarithm of 1. So you can write log and gets cancelled, x, y, z is equal to 1. That's it. X, y, z is equal to 1. Or even here, if you want by definition, if you remove the log, so k to the x, y, z is equal to k to the power of 0, because log of m to base n is equal to a means this x, y, z is nothing but k to the power of 0. Since what is k to the power of 0? So x, y, z is equal to 1. That's it. So you can simplify like this or like this. So this is the simple problem. See here, log x to base k plus log y to base k plus log z to base k is equal to 0, which implies this is of the form log m plus log n plus log p, that is log m into n into p, x into y into z to base k is equal to 0. 0 can also be written as logarithm of 1. So log and log gets cancelled, x, y, z is equal to 1. So, or at this point we can also write by definition of logarithm x, y, z to base k is equal to 0 implies k power 0 is equal to x, y, z. What is k power 0? K power 0 is nothing but 1. That's it. This is how we are going to solve this problem. Hope you followed. Okay. Let us come to the next problem. Logarithm of root a by b plus logarithm of root b by c plus log root c by a is equal to 0. Okay. Let us take LHS. Write down the LHS. LHS is log of root a by b plus logarithm of root of b by c plus logarithm of root c by a. Now, if you observe carefully, this is of the form log m plus log n plus log p. This can be written as logarithm of m into n into p. So, log m into n into p is log m plus log n. So, this can be written as logarithm of root of a by b into b by c into c by a. This is equal to logarithm of root of ABC divided by ABC. So, this is equal to logarithm of ABC by ABC is 1, logarithm of root 1 is 1, logarithm of 1 is 0, which is the required RHS. That's it. Very simple problem. Just multiply this. That's it. A by B into B by C into C by A is ABC by ABC. That's equal to 1. Root of 1, logarithm of 1 is 0, which is the required answer. That's it. Let us come to the next problem. Prove that 1 over log A to base B into 1 over log B to base A is equal to 1. Now, let us start with LHS. What is LHS? LHS is 1 over logarithm of A to base B into 1 over logarithm of B to base A. Now, using base change rule, changing the base to k, let us take k. So, this can be written as 1 over logarithm of a to base k divided by logarithm of b to base k into 1 over logarithm of b to base k divided by logarithm of a to base k. Take this to the numerator. So, this can be written as, whenever this is taken to the numerator, it becomes logarithm of b to base k and by logarithm of a to base k into this will goes to the numerator k logarithm of a by logarithm of b to base k. What happens? This is log b gets cancelled. This is equal to 1, which is a required RHS. That's it. Okay. See, that is 1. See, 1 over logarithm of a to base b into logarithm of b to base a, changing the base to k. If you change the base to k using base change rule, 1 by log a to base k by log b to base k into 1 over log b to base k divided by log a to base k. When just transfer this to the numerator, reciprocate it. If you reciprocate, this log b to base k goes to the numerator by log a to base k into the denominator log a to base k goes to the numerator by logarithm of b to base. Cancel the terms. These two gets cancelled. Log a gets cancelled. That's equal to 1, which is the required RHS. Okay. So, these are few problems based on logarithmic first and second and base change rule. Now, these are all for 3 marks questions. Suppose if they ask for 1 mark, let us take one mark question. 1 mark question will be like this. So, they will ask like this: solve for x if solve for x if log x to base 7 is equal to 2. Logarithm of x to base 7 is equal to 2. This is an important problem for 1 mark. If the problem is like this, solve for x if log x to base 7 is equal to 2. Now, according to the definition, this implies if you remove the logarithm, this base remains the same. 7 square is equal to x. So, therefore, x is equal to 7 square is 49. That's it. So, if you do this much, you will get 1 mark. Okay. Now, let me take one more problem. Solve for x if logarithm of 4 to base root x is equal to 2. Logarithm of 4 to base of root x is equal to 2. Here also, if you remove the logarithm, according to the definition, the base will remain the same. Root x whole square is equal to 4. So, what happens here? Square root gets cancelled. X is equal to 4, which is the required answer. That's it. Let us take one more problem. Third one. Logarithm of root 32 to base 2 is equal to x. This is the problem given. One more question. Now, according to the definition, what is this equal to? This implies 2 to the power of x is equal to root 32, right? So, that is nothing but, so therefore, 2 power x is equal to 32 to the power of 1 by 2. 2 to the power of x is equal to 32 can be written as 32 is equal to 2 to the power of 5. 2 to the 4, 4 to the 8 to the 16, 16 to the 32. So, this is 2 to the power of 5 divided by 2. Bases gets cancelled, therefore, x is equal to 5 by 2, which is the required answer. That's it. This is how we are going to solve the problems for 1 mark. Okay. These are few problems based on the properties of logarithms. So, that's all regarding today's session. Let us meet with the different concept in the next class. Thank you very much.